Go.
So today's lecture is going to be on ultrafiltration. And as you remember from the Chemi 160B class, if you took it, the ultrafiltration, actually I should clarify that if you didn't take 160B, you may still know what ultrafiltration is. It's basically a filter, which we know what that is. It has the membrane, and some things go through the membrane, but not everything goes through the membrane. But the special thing about ultrafiltration is that it is cross-flow, which means that the bulk fluid flows past the membrane, and because there's a pressure drop across the membrane that causes some of fluid to go through the membrane. So, depending on what is in the bulk feed fluid, there will be some smaller molecules that go through the membrane, but even some of the small ones will not go through the membrane because there's a bulk flow that carries them along. So the idea is that it's a low-cost, high-throughput method of filtration, as opposed to dead-end filtration that you would have to push it until the membrane plugs and then you got to quit. Okay, so this one, in principle, you don't need to quit. You can just keep going, and so that's the advantage of it. So we have here a lovely ultrafiltration apparatus. This is a little bit jury-rigged. I know you're going to be critical of that, but in fact it works, and we are able to put in a nice hollow fiber membrane system. If you want to get a little closer here now to see the system, here we go. Here, look, it's getting closer. There it is. Okay, this is the hollow fiber membrane system, okay? And these two ports here, this one and this one, are for the permeate. So what goes through the membrane comes out of this port, and what doesn't go through the membrane just continues straight up here and then goes out this tube here. Okay, so this is going to be your retentate, what is retained by the membrane. And what goes through the membrane again is the permeate. That one goes through here. All right, so how does this work? We have a pump and a tank. And the pump down here is going to flow the fluid from the tank through the membrane system down here. Down here we have a valve, which makes sense to leave it always open. Okay. Then we go through the membrane, okay, and then over here, which you can't quite see it, and I don't know if I can turn it towards you, but I'll just mention that there's a pressure gauge here, okay, PSI, and it has a, you can just read the PSI right there off the gauge, okay, and then up here is another valve. So what do we use the valves for? When we turn this, when we start it, we want to have this top valve all the way open, and you never have to remember righty-tighty, lefty-loosey, because there's an open arrow right there. So just turn it in that direction to open the valve. So you want to start with the valve open. What is that going to mean? The lowest possible back pressure so that the fluid flow through the permeate tube will be very little. All right? So what we're going to do now is we're going to turn the pump on. And believe it or not, we're going to press it to reverse. Okay? And that's just the way it's going to be. All right. We're going to press it to reverse because that's going to make the little guy go that way. And now we are going to have some flow through here. Now the pressure gauge is not all that easy to read, but basically the idea is that it's a peristaltic pump, so the pressure is fluctuating, right? So the pressure you want to read off the pressure gauge is the highest. So it reads a range, okay? The high value is the actual pressure that is being applied through that membrane. Okay. So now I can show you that even with the membrane all the way open, okay, there is a drizzle of permeate flow. This is it. You see that? Now, how are you going to measure that flow rate? Think about that for a second. Are you going to try to measure that in a 10 milliliter graduated cylinder with a stopwatch? I have a better idea. Why don't you fill the beaker, weigh it, and use the stopwatch? Okay, determine how much time it takes to get enough flow out. That's going to give you the most accurate reading for your flow rate. All right. But now watch. If I close the valve, all right, and so I can read here the pressure is now about 4 psi. Right? if I close the valve, and let's say I get the pressure at about 6 psi. There it is, 6 psi. Okay? All right, so now let's see what the permeate flow looks like. This is artificially fast because we've got to drain the tube first. Okay, so what you want to do is once the tube is drained, now we're reaching the point where we can follow how much is actually coming out of here. Okay, so we can measure this flow rate, and that will be 6 psi. So part of the lab is to measure the flux. Flux is the flow of the permeate, okay? And that we're going to measure that as a function of pressure. All right. So that pressure is clearly the pressure drop across this membrane. Okay? How do we know that's a pressure drop? Because what's coming out here is atmospheric. Okay? All right, so this is going to be the retentate, and right now I'm returning the retentate flow to the tank. Part of your experiment is going to be to measure the rejection coefficient of the membrane for milk protein. That's going to be the experiment that you're going to do. So you're going to need to measure concentrations of protein in the milk. The concentration of protein is read off the label from the bottle of milk. So you buy the milk, I'll buy the milk, you read the label, and it's going to say how much protein there is in milligrams per serving or whatever it is. So you have to convert that into milligrams per liter, and so then you're going to use the total protein method that I've instructed you to use with the UV visible spectrophotometer, and we are going to measure the protein content of the permeate, okay,